On the previous problem, we had looked at sine being the vertical distance over the hypotenuse, and then our cosine was the horizontal distance over the hypotenuse. Okay, well, in the trig, we look at triangles quite often, so the mathematicians have come up with a mnemonic to help us remember. So we've got this thing called Soh-Cah-Toa, right? So Soh-Cah-Toa. So I'm just going to go ahead and break those up. And then what this mnemonic does is it helps us remember that our sine of theta is equal to opposite over hypotenuse. So we're just using the first letters there. So is S-O-H, which gives us the sine is equal to opposite over hypotenuse. The Ka is going to be our cosine theta equals adjacent over the hypotenuse. Again, those letters are just the first letters here. So the Ka is C-A-H. And then the last one, we have not yet talked about the tangent function, so I'm going to go ahead and introduce that here. So Toa is tangent of theta equals the opposite over the adjacent. So again, those letters, the Toa is T-O-A. So this mnemonic is super helpful because it helps us orientate our triangles, because we can take our triangles and flip them in any orientation. And so we kind of start to lose which one is the vertical distance and which one is the horizontal distance. And so now we just need to think about them as opposite over adjacent to the angle that we're looking at. And it just makes it a little bit easier to work with triangles instead of trying to figure out which side is vertical, which side is horizontal. Okay, so one of the things with our triangles that I want to point out is that if we start off with this triangle right here, here is our right angle, so opposite that is going to be the hypotenuse. And then depending on which angle we are looking at, so if I am looking at this angle right here, that means that this side over here is going to be the opposite, and then the side next to is going to be the adjacent. And that's exactly what the word adjacent means. Adjacent means next to. So if we take that same triangle and now we're going to be looking at this angle over here, that means that this side over here is now going to be the opposite, because it is opposite of the given angle. And then here again, this pink angle, now this side right here, which is the vertical distance, is going to be the adjacent side, because this side is next to that purple angle. Okay, so let's apply this back to problem number 4. So on problem 4, we had that given angle, and earlier we talked about it as the vertical distance is 6.6 and the hypotenuse was 10.6. But now, instead of thinking about the 6.6 being the vertical distance, we now want to think about it as the opposite side of that angle. And so notice if we use that sine of theta equals opposite over hypotenuse, we get the same thing. Sine of theta equals opposite of 6.6 divided by our hypotenuse of 10.6. Very similar to applying that cosine, that the horizontal distance in problem 4 was 8.3. We now know that to be the adjacent side of our triangle, and so we still get the same solution. So adjacent of 8.3 divided by our hypotenuse. And so this mnemonic right here becomes super helpful when we have a triangle that doesn't quite necessarily fit that vertical and horizontal. So if we had this triangle right here, and this is our 90-degree angle, we know that this side is going to be the opposite, but if we look at it from the circle perspective, it's sometimes hard to know which side is the vertical distance, which side is the horizontal distance. But using this mnemonic of Soh-Cah-Toa and just thinking about the triangle, we don't need to worry about that anymore. So if I am looking at this angle here, we know this side is going to be the opposite, and then this side is going to be the adjacent because it's next to that angle. All right, on problem 6, we are going to be looking at the tangent of theta, again, without determining the value of theta itself, so we don't need to do the inverse. But tangent of theta is going to be the opposite over the adjacent. And so on the triangle here, you can see that this is going to be the angle we're looking at. So that means that the 5.33 is going to be the opposite. The 10.62 is going to be the adjacent because it's next to the angle. And then that 11.88 is going to be the hypotenuse. So when we're trying to find our tangent of theta, we're going to take our opposite value of 5.33 divided by our adjacent side, which is 10.62, and that gives us our solution. So tangent of theta is really just the ratio of the vertical distance over the horizontal distance. And that's really all it is. I never talked about it when we were looking at circles, but in triangles it shows up a lot more. So that's why we're covering it here. Next we have problem 7, and we're going to use the triangle below to determine the following. So we're going to first use our knowledge of sine or cosine to determine the measure of theta. So this is the first time we are looking at finding theta by itself, which means that we need to use the inverse. Okay, and it doesn't matter if we use sine or cosine. I'm going to show both just so you have that knowledge. Okay, so we will do sine of theta. So remember, sine is so that means it's going to be the opposite over the hypotenuse. If we look at our triangle, the 1.78 is the opposite. The 3.96 is going to be the hypotenuse. And then since we're labeling, let's just go ahead and label this side as the adjacent. So our sine of theta is going to be equal to 1.78 over our hypotenuse of 3.96. And so now we want to take the inverse of this. So remember, the inverse is that we switch the inputs and the outputs. So this becomes sine inverse of 1.78 divided by 3.96 is equal to theta. So now we have theta all by itself. And then we can plug in this value of sine inverse of this fraction into our calculator, and it will give us the value. This problem didn't specify if it was in radians or degrees, so since it didn't specify, both answers would be acceptable. When you are working with the homework, make sure you pay attention to if it's looking for the value in radians or degrees. So plug it in the calculator, we get 0.466 radians, or we also would get 26.7 if we're in degrees. Okay, so that gives us our theta value. Okay, and we also could have used cosine to find the same exact thing. So we get cosine of theta equals the adjacent of 3.54 divided by our hypotenuse of 3.96. We then want to take the inverse to switch our input and output. To get theta by itself, and we get the same exact values. When we plug this one into the calculator, we get 0.465 for the radians, and sometimes that happens where we're off just a snitch, so this one's off by 1/1000th of a radian, and that just is due to rounding because the hypotenuse or any of those lengths on the triangle might just be a rounded value. Same thing with the degree, we got 26.6 degrees. All right, for part B, it says let the third angle be represented by alpha, and then we want to determine the measure of alpha. So there's actually multiple ways that we can find this. So let's go back up to our triangle. The angle at point A is now going to be our alpha, because that is the other angle that is missing, which means that the names of our sides are going to change. So according to this alpha, the 3.54 is opposite of that angle. And then the 1.78 is actually the adjacent because it is next to the angle. The hypotenuse will always stay the hypotenuse because the definition of a hypotenuse is that it is opposite of that right angle. All right, so we can use either sine, cosine, tangent, or the angle sum to find this answer. So what I want you to do is go ahead and pause the video and use whichever method you want, and then I will show the solutions in just a second. All right, so it doesn't matter which one of these you used. So if you did sine, your solution's going to look like this. Your cosine work is going to look like this. If you use tangent, your work is going to look like this. And notice all three of those we end up with the same solution of 1.106 radians or 63.4 degrees. Okay, one other option was to use the angle sum. So every triangle has an angle sum of 180 degrees. So we know there's the 90-degree right angle. We found from part A that the theta measure was 26.6 degrees. And then we don't know our alpha, but we do know that the sum of them must be 180. So then solving for that, we get alpha equals 63.4 degrees. All right, last we have problem number 8. So we're going to use this diagram below to determine each of the values. One of the things to be careful of is that when we're solving for part A, you don't need to do the inverse quite yet. You just need to find sine of alpha. Same thing with B through F. You do not need to do the inverse quite yet. It's when you get to G that you will want to do the inverse. Sometimes we've done the work on problem 7, so then students immediately want to find alpha and beta when they do parts A through F, but you don't need to do that quite yet until you get to part G. So go ahead and pause the video, and I want you to solve this problem. All right, let's go ahead and go over the solutions. So for parts A through C, when we're looking for the alpha, I've got that highlighted in pink. Make sure you have 6 as the opposite, 2 as the adjacent. And then for D through F, when you're looking at the beta, I have that highlighted in blue. This time make sure the 6 is the adjacent and the 2 is going to be the opposite. And then part G, we actually want to find the angle measure. So alpha is going to be 71.5 degrees or 1.25 radians. And then the beta is going to be either 18.5 degrees or 0.322 radians. Again, when you are working on the homework, make sure you are paying attention if it wants it in radians or in degrees, because it will be asking for both, so that way you get used to working with both angle measures. All right, let's go ahead and do the 8.1 summary. So when we are looking at the circle, the sine of theta is always going to be our vertical distance divided by our radius. Very similar when we are looking at our triangle, the sine is going to be the opposite over the hypotenuse, which notice that that opposite side is still our vertical distance, and that hypotenuse is still our radius. With our cosine function on the circle, the x is our horizontal distance divided by our radius. And then when we compare it to our triangle, the cosine is going to be adjacent over the hypotenuse. Again, that adjacent side to the angle is always going to be our horizontal distance. And then again, our hypotenuse is still our radius. Okay, and then the tangent, when we look at it from a circle perspective, which we actually haven't quite done yet. So our tangent is just the ratio of the vertical distance divided by our horizontal distance. But remember, the vertical distance is really our sine function, and the horizontal distance is our cosine function. So that means that tangent is equal to sine over cosine. And then when we connect it to our triangles, the tangent of theta is opposite over adjacent. That opposite is still our vertical distance. The adjacent is still our horizontal distance. All right, that is it for the 8.1 worksheet.